Hi everyone, in this video I'm going to provide an introduction to working with datetime in Python. Now this can initially be a daunting task because there are plenty of libraries for working with datetime. We're going to start with the most basic, which is the built-in datetime library in standard Python. And then the ultimate goal is to move on to datetime functionality in Pandas. So this will rely on some Pandas knowledge from previous videos, but not too much, but do check them out if you're new to Pandas. I will mention that the Pandas functionality is built on the NumPy datetime functionality. There's this really handy data type called datetime64, which is a more high-performant version of the original datetime object that was built custom for NumPy. We're not going to go into the NumPy implementation. We'll just start with the basics with the simple standard Python datetime library, and then we're going to transition over to the equivalent functionality in Pandas. So let's get started. Here's the documentation for the datetime library. You can see it supplies classes for manipulating dates and times. These classes are listed on the left side here. So for example, there's time delta, date, datetime, time, tzinfo, and time zone. Let's start with the date class. So if you have information just about the date, for example, the year, month, and day, nothing about the time, like it's 12:09 p.m., none of that, then you'll use a date object to store that information. Let's say you just have the time information, like the fact that it is 12:09 p.m., not necessarily tied to any particular day, then you'll use the time class and make a time object to store that data. Now, typically, you'll have both date and time information, and these can be stored in a single date-time object. We're going to be working with the date-time object, getting started here now. I'll also mention while we're here that often you want to do some arithmetic between, say, date-time objects to figure out like how many days ago was this date, or how old is somebody based on their birthday and today's date. And that's where the time delta object comes in. It represents a duration or the difference between two date time instances, and you can also do this calculation with date instances. Okay, so let's get started with datetime objects. So previously, I had been working in this Pandas fun folder, and we had done some intro to series and data framework with simple city population data. Rather than messing with that main.py, I'm going to start with a fresh main.py called dtmain. And the reason why is because we're not going to be starting with Pandas, we're going to be starting with datetime. So this is typically how you import the datetime class from the datetime library. I know it looks kind of strange, like from datetime import datetime, but this first datetime is the name of the library or the module. This second datetime here is the name of the class. So the theme I'm going to use for this video is going to be, say, social media posts, like the time a tweet was made or the timestamp of a post on Instagram, something like this. You can think of any context, any kind of date, time series context you'd like, but that's the theme that I'm going to stick with for this video, mostly because it's, highly relatable, but I've also got some interesting tweets data that we're going to use here in a little bit. So first, let's say we have a tweet timestamp stored as a string. So I like to use TS, short for timestamp, and I'm just going to make this up. So let's say there was a tweet that was posted on, let's say, the first of this year. It is 2025 at, let's say, 11:05 a.m. So we would use 24-hour time, if I were to go past noon. So for example, if it was like 1:05, it'd be 13:05. But we'll just keep it simple and just say this is 11 a.m. for the noon hour. So this is a string, but the goal is to actually store the contents of this string as a datetime object so I can get all of the nice built-in functionality from the datetime library. So I'm going to do tweet ts dt, because I like to, in my mind, know that when I look at a variable and see dt, this is a datetime representation, right? So then I know I get the datetime API when I want to do things like maybe figure out what is just the the year or the hour or start doing time delta stuff. So how we create a date time from a string is we use this really handy datetime function called stir ptime. So I'm going to do datetime.stir ptime. The way I remember this is string parse time. Okay, so we're going to parse a time from a string. And we're going to pass in our string representation of the date time. And then we also have to pass in the format that this date time is in this string. So we've got some handy format string placeholders here. So year-month-day space hour colon minute colon second. And I will show you where you can look these up. You do have to know these, right? This has to match this format here. And there are a lot of different placeholder codes, so you need to know them. So let's say I print this out. I see output that looks just like line 3. So I'm like, how useful was that? But let's say I print out the type of the object that this variable refers to, and bam, this is a datetime.datetime object. That's awesome. That means that I can do things with this object that I can't do with a normal string. For example, I can just grab the month, or I can just grab, say, the hour. Oops. That was proof that I could not grab the hour from the string. So we see the month is 1 and the hour is 11. That's awesome, right? I can't do that with the string, but that functionality is exposed from the datetime class. So let me show you where you can look these up. So still on the documentation for datetime, if I go down here to stir ftime, so this is parsing a string from a time, and stir ptime, parsing a time from a string, you can see there's format codes, and here's where they all are. So for example, %m, this is month as a 0 padded decimal number. So that's what we have here, month as a 0 padded decimal number. So you have to look these up and know how to create that format string using the format codes so that datetime stir ptime can actually parse a datetime object from your string. Awesome. So far, so good. So now let's do something fun. Let's calculate a time delta. Let's see how long ago January 1st, 2025 at 11:05 a.m. was from the exact date time now. So I'm going to create a now DT object, and this is simply datetime.now. Datetime can grab this from your operating system time. Let's print that out so we can see what it looks like. Here it is. So it is June 3rd, 2025 at 12:16 p.m. So let's do time since tweet. And this is a time delta object. So put a TD on the end if you'd like, totally up to you. Now DT minus tweet TSDT. This is so cool. The fact that this subtraction is defined as an operator between two datetime objects is really, really valuable. So this tells me that this was 153 days ago, right, when this imaginary tweet was posted on January 1st, 11:05, and 1 hour and 12 minutes ago. And that makes sense, right? 11:05 difference 12:17. Yeah, that would be an hour and 12 minutes. With this time delta object, we can also access some of its attributes. Like, let's say we want to just grab the number of days. So we can get 153. Or I often find total seconds to be really helpful because this can give you, just single floating point number that represents the total difference in terms of seconds. So keep these in mind as you might try to be comparing two time deltas to see like which one's smaller, which one's closer, those kinds of things. Okay, now let's see stir ftime in action. So stir ftime is how we can get a string from a datetime object. So let's do tweet ts stir 2. This is going to be the tweet ts dt datetime object parsed into a string. And here's where we get to choose how we format this datetime object. So for example, we might store the datetime in a datetime object and then show it to a user in different ways. Maybe if we have a lot of screen real estate, we might actually spell out the word January. Maybe if we don't, we might do an abbreviation, or maybe the date isn't relevant at this point and only the time is. So we're just going to show the time. So that's where these format codes come in handy. So let's try this format string and see how it looks. %b space %d, comma, %y at %i colon %m space %p. You can probably guess what this is going to look like. So the %b gives us an abbreviated English name for the month. %d we've already seen before, same with %y, but we have a comma here, and then we have 11:05 a.m. So the %p is actually showing us the a.m. p.m. So this is not 24-hour time, this is 12-hour time. So locale is equivalent of either a.m. or p.m. And then %i, you can see here, is the 12-hour clock as a 0 padded decimal number. So here's %b, month as locale's abbreviated name. If you want the full name, like let's say I want January spelled out, just change this to a capital B, and I've got this. So this might be what I'm going to show to the user, or maybe going to write out to a file that I know is later going to be incorporated into, say, Excel, and I've got a user who really wants to see kind of a long name. So you can customize this output, which is really, really handy. Now, I'm not going to go into too much detail on working with time zones, but I will say a few things about it. So first, by default, datetime objects are naive, which means they have no time zone info. That's kind of what the beginning of the documentation is talking about here. If you need to, you can make your datetimes time zone aware. There's a few ways of doing this. In newer versions of Python, it's recommended to use the zone info library. In older versions, it's forward compatible, you can use PyTZ. I'll show you an example of using the newer zone info. So from zone info, import zone info. And what I'm going to do is I'm going to make my tweet dt time zone aware datetime object. So I'm going to replace its time zone info with the zone info for my time zone, which is Pacific time zone, represented with the code America LA. So now you'll notice that when I print out this time zone object, on the end now, there's a -08:00. And let me take a moment and briefly explain this, because this is one of the trickiest things about working with date times. This is the primary time standard globally used to regulate clocks and time. And how it works is, if you live in this green band of the world right here in the center of the map, then your time zone is UTC, and there's no offset calculated from your time. Now, as you move east, you have to add 1 or more hours of an offset to get the localized time, and as you move west, you have to subtract 1 or more hours to get the localized time. So for example, if I have a date time object and it is aware of its time zone is UTC, and I want to localize it to my time zone, which is Pacific Standard Time LA right here, then I would need to subtract 8 hours to localize it. So what I always recommend people do, and what I do myself, is I always store my date times in UTC. And I can do all of my, say, time delta calculations in UTC. As long as they're in the same time zone, it works out just fine. The only time you really need to, say, localize your time is if you're about to show that time to the user and they expect it to be in their time zone, or if you're doing some sort of calculation that needs to be localized first. So briefly, our datetime now object right here is going to be returning a datetime object that is naive, but is based on the system time, which we know is based on a time zone of the operating system. If you wanted to, say, put some time zone information on here, let's say I want to make this aware that it's in UTC time, I could do timezone.utc, and then if I run this, you see that the current time has now changed, and it has an offset here of +000. This also broke, though, our time delta calculation because it's saying can't subtract offset naive, which would be this tweet TSDT, and offset aware date times, which would be this now DT. So there's actually some built-in functionality here to protect you from trying to do some calculations when your time zones are not aligned. So that's why, like I said, just to minimize any errors, I would just always store date times in UTC. So I'm going to undo this for now. And I think we are ready to move on. So we've been working with the datetime library, and now it's time for moving on and working with the equivalent functionality in Pandas. And this is going to be kind of fun because I have a data set here called tweets2223.csv, which has some real tweet information from two teams, the Gonzaga women's basketball team and the Gonzaga men's basketball team from the 22-23 season. Now, according to the developer agreement for Twitter, or X, I'm not supposed to be just posting tons of raw tweet information. So I've trimmed this down to roughly the first 10 tweets of the season from the women's team, the last 10 tweets of the season from the women's team, and then the same for the men. So here's the last 10, here's the first 10. So you can see here that we have a username, which could be used to identify which team the tweets came from. If I wanted to do some like men's and women's comparison, I could do a group by username, and then I would have the, say, women's data frame and the men's data frame. Here I have created at UTC, and this is nice because the name of the column is actually telling me that this timestamp is in UTC. So I'll need to make sure that my datetime objects, or working with Pandas now, our timestamp objects, are aware that they're in UTC. And then there's some extra information about the impact or the impression of the tweet, how many times it was retweeted, replied, etc. And then here's the text for the tweet. We're not going to be doing anything with any column except for this created at, because the goal of this video is to work with timestamp objects in Pandas. So all I'm going to do here is import pandas as PD. And I'll be making a note here. Switching now to datetime functionality in Pandas, which is namely the pd.timestamp class. It's kind of like the equivalent of the datetime class that we've been working with. So let's do read CSV tweets _ 2022 23 CSV. df.head is a nice little handy method to view the first 5 rows of a data frame. All right, perfect. So now here's what we're going to do. We're going to print out df sub created at UTC. So I just want a series for the timestamp column. Here it is. Looking at the output of printing the created at column, we see it's a series with data type object, which means that all of the values are strings. So we want to do something like we did up here on line 7, where we parse a datetime object from each of these strings. The equivalent of this in Pandas is this handy toDatetime function. We'll pass in our series, which as our parameter shows here, we can do. And Pandas will attempt to figure out the format and parse datetime objects from it. If it can't, we can always pass in the format explicitly like we did for stir ptime. So let's try this out. I'm essentially going to attempt to overwrite this created at column with itself, but after we call toDatetime and ask Pandas to convert all of these string values to datetime values. So if I run this now, it looks like success. So our output looks slightly different here. Like for example, we're seeing zeros for seconds appended to the end. And the data type for the series is datetime 64, which comes from the fact that these Pandas timestamp objects are based on the NumPy datetime 64 data type. Before we move on and see that these are in fact Pandas timestamp objects, I'd like to make a little note that we should set a flag when we call toDatetime, which is UTC true, to let datetime know that these values in this column, this series, are in fact already in UTC. This is important because it can make all of our timestamp objects time zone aware. So you can see that now when I run this, I get the +00:00, which is the offset for UTC 0. So it's good to do this because it'll provide this extra bit of information that we already know based on this nicely labeled column name. So same thing before, you can go to the documentation and be able to see there's a Boolean here, UTC. It defaults to false, but we can set it to true. So the function always returns a time zone aware UTC localized timestamp. Okay, cool. So now what I'd like to do is I'd like to show you that each one of these values in this column now is in fact a Pandas timestamp object. So let's just print out the first one and let's print out the first one, and then what we'll do is print out the type of the first one as well. So we'll see the string representation of the timestamp object. Here it is. And then we'll see that the class is Pandas timestamp. So this is just a little bit of evidence showing that we are working with Pandas timestamp objects here, not datetime objects like we were working with at the beginning of this video. Next, what I'd like to do is show you that arithmetic, like subtraction, works with these Pandas timestamp objects. So we can easily get a time delta. Let's say we want to subtract the second date from the first date. So this will give us, let's do TD for time delta. We'll print out the time delta and then the type of the time delta. So this is going to tell us the difference or the time distance between the first and the second timestamp in the series. So that's 7 days, 4 hours, and 29 minutes. And if we scroll up and look, it does look like there's 7 days between March 29th and March 22nd. And the 4.5 hours or so seems pretty accurate based on these two times here. So awesome, that worked. And then it says that the class is Pandas time delta, which is Pandas time delta. Perfect. So just like we saw earlier with the date time delta, we can access some, valuable attributes and methods on the object. So for example, seconds, this will return the total hours, minutes, and seconds of the time delta as seconds. This is like the total seconds that we saw earlier. So definitely check out the documentation if you need to be calculating differences between timestamps for your data. Now what we're going to do is just see a bunch of really handy features of Pandas timestamps, and these might be applicable for some of the projects that you're working on. So let's see a few in action. Let's see how we can say make another column and add it to our data frame. So let's say we just want the hour of every created at timestamp. So I'm going to go and grab the created at UTC column, and then .dt on the series, the column, will give me access to some datetime functionality that can be broadcast to every value in the series. And I'm going to say I want the hour. So now if I print out df.head, I see that there is an hour column at the end, which has just the hour. I could do this for month or day or year, and this could be really handy if I wanted to do some split apply combine and perhaps say group by hour or do some filtering by hour. In fact, I'll show you how to do the filtering by hour here in a moment. I also want to show you dt.dayname. Oftentimes you want the name of the day of the week, for example, Tuesday, Sunday, etc. This is also an attribute or a feature that we commonly do a group by on so that we can do analytics across days of the week to look for patterns or trends. So we can see that March 29th, 2023 was a Wednesday. So I could use these new columns for some filtering. Maybe I don't want to make a new column, but I want to make a new data frame, which is a filtered subset of the original data frame. So I'll call this like afternoon DF. So this will just simply be our data frame, sub data frame hour, which is greater than or equal to 12. So if we're looking at the hour column, these all have hour greater than or equal to 12. So these were tweets that were posted in the afternoon. I could actually do this another way. I don't have to make this intermediate column first. What I can do is use the created at UTC column again, .dt to get that date time functionality that can be broadcast across every value in the series, and do hour greater than or equal to 12. So I'll get the same output doing it this way. And then let's see a little group by here for day of week. So let's say I want to grab, looks like there's a lot of Monday tweets. So let's do Monday DF. So I'll do df.group by day of week. And then I'll do .get group, and I'll just get the Mondays. So here's all of the tweets that were on Monday. The last date time functionality with Pandas that I want to show you in this video is resampling. So first, in order to do that, we're going to need to set the index of our data frame to be a date time index. Naturally, we'll just use this created at UTC column because we've already done the work to make it into a date time column. So we'll just set it to be the index of our data frame, which will make our data frame have what's called a date time index, which unlocks a lot of additional functionality, such as resampling. So first, in general, I wouldn't say that a created at column is guaranteed to be unique. People, teams, accounts, etc. could post tweets at the same time. Now, for this little demo, it's going to be okay. In fact, I can, write a little bit of code to make sure that it's okay. But just think about that in the future when you're going to be setting a column in your data frame to be the index. Is this column a good index? Does it uniquely identify the rows in the data frame? Is there any chance of duplicates, etc.? So just for now, how about we just print out created at UTC and the value counts for each of the unique values in this column, and we'll sort it so that we can easily see if there's any value count greater than 1. So it looks like they're all 1, which tells me we don't have any duplicates. So initially I'm feeling okay about setting this created at column to be the index of the data frame, but that works just for this little data set. Like I said, we could have tweets from different teams, for example, that are created at the same time. So what I'm going to do is I'm going to call setIndex on our data frame and set it to be created at UTC. And since I'm not going to be using the assignment syntax here, I've got to set in place to true so that this set index change persists to our data frame in memory. Now, if I print out the data frame, I'm going to notice a few things. First, it looks like created at UTC is slightly lower than the names of these columns. That's telling me that it is, in fact, the index. And if I print out the data frame index directly, that this data frame index is not the standard range index or index that we're used to. It is what's called a datetime index. And that means there's a little bit of additional information or metadata about the index that we can leverage with some Pandas functionality. So for example, the type is datetime. See that it knows that it's stored in UTC format. And there's also a frequency here, which is none. So if our samples, all of the values in this index, were evenly distributed or sampled regularly, then there would be a frequency. For example, if we had 1 tweet per day every day, then the frequency would be daily. But since there's really no rhyme or reason to the spacing between each of these date times or these timestamps, the frequency is none. But I can use the resample method in order to build what's called a resampler that'll allow me to aggregate over different frequencies. So here's a little use case that we can use for demonstration purposes. Let's say I want to count how many tweets were created each day. So I'll call this like daily counts ser. And this is going to be the data frame where I'm just looking at the tweets column. And I'm going to resample this series, which is just all the tweets in the text column, to be daily. And then I'm going to call count to count the number of tweets per day. So this actually does a few interesting things for us. So first, we can see how many tweets were posted each day. So for example, on November 7th, there were 5 tweets. Let's go look at November 7th. 1, 2, 3, and 4, 5 between the two teams. Perfect. But then there are also some days in here that don't have any tweets, which doesn't initially make sense, right? Like, let's see, March 31st, there were no tweets in this data set on March 31st. So why is March 31st here? Well, when we set the frequency to be D for daily, essentially we're interpolating all of the days from the minimum, right, the oldest date, to the maximum, the newest date. So that's two things that happens here. One is that kind of regular frequency interpolation, and then the aggregation, which we have to apply some sort of aggregate function like count in order for that aggregation to occur. So definitely keep resample in mind. It can be really helpful when working with datetime objects. It can give you a regular frequency for your data That means you can take advantage of things like the spacing in between adjacent values in your series or your data frame. This can be helpful perhaps if you're going to do things like computing rolling averages or try to downsample by taking every 7th day, right? Something like this. Well, we covered a lot in this video. We started with the OG datetime library in Python, and then we migrated to the Pandas library, and we saw timestamp and the time delta classes in action. So you have a good foundation now to start applying your own analysis to your data sets that have timestamps in them. Happy coding, and thanks for watching.